This video is for simultaneous equations, all linear, and we're working with 3 variables. We are trying to find the x, the y, and the z that fulfills all 3 equations. Yeah, we're going to get the same x, the same y, and the same z for all 3 equations. So the way we solve this equation is by eliminating one variable after the other. Yeah, so we can only solve if we have one variable. So we need to eliminate 2 variables in order to be left with just one variable, and then we solve it, and then we take this variable and then find the other ones. So the way we eliminate variables is by adding equations, but we are looking for a situation where we, for example, have a plus 2y and a minus 2y. And then we can add that and we get 0. So we need the same letter, yeah, the same variable, the same number, but we are looking for opposite signs so that if we add the 2 of them together, we will get 0. And we can manipulate these equations, we can multiply them, and in order to get to a situation like that. Okay, so let's look at our 3 equations. I labeled them A, B, and C so that we can keep track of what equation we are working with. So if you look at this equation, I think the first variable we should eliminate is y, because I think we can start fairly easy here. So we take these 2 equations, I write them out again. And C, 4x plus y minus 2z equals 3. So I add these 2. 2x plus 4x equals 6x. Minus y plus y is 0. So this is eliminated now. And minus z minus 2z is minus 3z. And that equals 6 plus 3 is 9. Okay, so I have one equation. Now I have to do that again. I need to get a second equation, and I also need to have eliminated the y. Okay, so I can get rid of that again. Right, so I think another good one would be the A against the B. But as you can see here, I have plus 2y here, but in the A I only have a minus y. So I need to multiply the whole equation by 2 so that I can get a minus 2y there. But I need to multiply the whole equation. So I can write here 2a. That's what I have, 2a now. So 2 times 2x is 4x, and minus 2y minus 2z, and 6 times 2 is 12. And then I write b again. So 3x plus 2y plus 3z equals 3. So now I add these 2. 4x plus 3x is 7x, minus 2y plus 2y is gone, minus 2z plus 3z is plus z, and 12 plus 3 is 15. Okay, so now I have 2 equations with 2 variables, and I can do the same thing again. So I write them out again. So 6x minus 3z equals 9, 7x plus z equals 15. Okay, so I have here, if you look at this, power z and a z, so that is okay. I have a minus and a plus, but on top I have a 3, and on the bottom I only have 1. So I need to multiply this by 3. Okay, let me write them again. 6x minus 3z equals 9. So I multiply the bottom one by 3. 7 times 3 is 21x, plus z times 3 is 3z, and 15 times 3 is 45. I add these two together. 6 plus 21 is 27x, minus 3z plus 3z is gone, and 9 plus 45 is 54. So now I can finally solve it. So I divide both sides by 27, and I get x equals 2. So I found the first variable. So now I take this 2, the x equals 2, and I put them in here instead of this x, so that I can find the z. Okay, so I write 7, so instead of x I write now 2, because I know the x is 2, plus z equals 15, and now I can find the z. So 7 times 2 is 14, plus z equals 15. Okay, so I bring the 14 over, 15 minus 14, and z equals 1. Okay, so I found the x and the z, and now I need to find y. So I take these two variables and I put them into one of the three original equations. So I think b looks the best. So I write out b again. So b was 3x plus 2y plus 3z equals 3. Okay, so now I know x is 2. I don't know y yet, but I know that z is 1. And that equals 3. Okay, so I can 6 plus 2y plus 3 equals 3, and now I can find y. 2y plus 9 equals 3. I bring the 9 over. 2y is 3 minus 9. 2y equals minus 6. I divide by 2. Divide by 2. And I get y equals minus 3. So now I have found everything. I found the x equals 2. I found the z equals 1. And I have found the y, and y equals minus 3.